to show you an example of solving polynomial inequalities. Okay, so my first example, my only example actually of this is going to be find the solution set for this inequality. So in other words, find all of the x values such that when we plug them in here, so 2x plus 1 over x minus 1 minus 2 over x minus 3, that answer, that the quantity is less than 1. Okay, now just as with equations or equalities, I can do the same things or most of the same things with inequalities. So the first thing I'm going to do is move everything over to one side. Okay, so I'm going to subtract the 1 over, and I get 2x plus 1 over x minus 1 minus 2 over x minus 3 minus 1 is less than 0. Okay, so I just subtracted 1 from both sides. Now your instinct might be to multiply through by x minus 1 over x minus 3, but unfortunately we can't do that because x minus 1 times x minus 3 for certain values of x could be negative. If I multiply through by a negative number, I have to switch the inequality direction, and I don't know, I can't tell because x could be such that this is positive or negative. So I wouldn't know which way to switch the sign, the direction of the inequality, so I can't do that. Okay, so just remember that with inequalities, you can't multiply through by the denominator because we don't know how that switches the direction of the inequality. Okay, so the thing I'm going to do here is I'm going to get a common denominator. Okay, so just like before in the other video, the common denominator is just going to be we are going to prime factor each of the denominators of our fractions. Okay, so this x minus 1, it's already done. We can't factor it anymore. It's a simple linear expression, as is x minus 3. Can't factor that. And then here we've got 1 over 1. 1 is clearly, you can't factor that anymore. So my common denominator is x minus 1 times x minus 3. So now I need to multiply each term by the form of 1 that gives me the common denominator. So here, 2x plus 1 over x minus 1, I've already got the x minus 1. I need to multiply by the x minus 3. So I multiply by the form of 1 x minus 3 over x minus 3. So that multiplies by 2x plus 1 over x minus 1. Now I have my common denominator here. Okay, here we already have x minus 3. I need x minus 1. So I'm going to multiply top and bottom by x minus 1. This is my form of 1 that I'm choosing. Times 2 over x minus 3. Now here on this 1, I don't have either. So I need to multiply by both. So I get times x minus 1, x minus 3. X minus 1, x minus 3. And this is times what was already there, 1. Okay? Now, nothing's changed. I've only multiplied each of these things by some form of 1. So I still have less than 0 on this side. Okay, now let's just go ahead and simplify. Multiply everything out except for the denominator. You'll see why we don't multiply the denominator out later. Okay, so if I do this, I get, let's see, 2x squared minus 6x but plus x. So minus 5x minus 3. If you're following along, I encourage that you pause and try multiplying these out yourself and make sure that we get the same thing. It's just good practice. Okay, and then that's over x minus 3 times x minus 1. And then that's minus, now 2 times x minus 1. This is 2x minus 2 over x minus 1, x minus 3. Okay, and then this one, when we square out the top, we get x squared minus 4x plus 3 all over x minus 1, x minus 3 is less than 0. Okay, so now these are fractions with the same denominator, so we can combine the top. So I'm going to get 2x squared minus 5x minus 3. Now this minus sign distributes between these two terms. So I get a minus 2x and then a minus 2, which is plus 2. And then this minus also distributes. So I get minus x squared, and then minus a minus 4x, which is plus 4x, and minus 3. All over x minus 3, x minus 1 is less than 0. Okay, let's simplify that a little bit more. This simplifies 2x squared minus x squared. I have just 1x squared on top, minus 5x minus 2x, that's minus 7x, but plus 4x, I have minus 3x. And then finally, minus 3, but plus 2, that's a negative 1. Minus 3 is negative 4. All over x minus 3, x minus 1. Now let's factor the top. We'll end up with x, let's see, minus 4 plus 1 over x minus 3, x minus 1 is all less than 0. Okay, so we're looking for the places where this expression is less than 0. Okay, so all we've done a whole bunch of manipulation to simplify it so that we've got one single fraction is less than 0. Okay, one single fraction with linear expressions in x if possible. Sometimes it's not possible to factor, but we want, if possible, linear expressions in x. That just means only a single, the power on x is just 1. No x squareds, nothing like that. Okay, now we're looking for places where this is negative. The way that we find those places is we actually find what x values make us switch from positive to negative values. Now the places where that happens, so places where our expression can switch sign, where it can go from positive to negative. Now those places are places where either our value is 0, okay, so this is, for any x value, this is some number, okay? So if we imagine that this is some function of x, so for any x value, we could graph this. It looks maybe something like that. The places where it switches sign will have, will occasionally have pass through y equals 0, or this value will be 0, okay? So we want to look at places where this is equal to 0. Okay, so I'm going to call those zeros or roots, okay? Okay, so zeros or roots, places where we get this whole thing is equal to 0. Now, if this whole thing is equal to 0, that means the top is equal to 0. The reason that we wanted to factor this is because we want to use the zero product property of real numbers, which we talked about in class on Monday. So the zero product property of real numbers says that if two numbers multiplied are equal to 0, then one of them or both have to be 0. Okay, so if this whole thing is equal to 0, the top has to be equal to 0. Okay, that's just true of fractions. So we end up with either x minus 4 is equal to 0 or x plus 1 is equal to 0. So our zeros, or our x values, where we end up with this being 0, our zeros are our roots, are x equals 4 and x equals negative 1. Okay, now that's only some of the places where our expression can switch sign. The other places are where our expression is undefined. Okay, now the reason that we need to look at places where our expression is undefined is because occasionally you can have functions that look something like this, where on one side we're shooting off to infinity, and on the other side we're shooting down to negative infinity.